Question 1a was what we did in class number 5. Question 1b, however, is going to take our work a step forward. Note in question 1b, they're asking us to write the equation of each horizontal tangent to the curve. Recall that we said horizontal tangents means that the slope of the tangent line has to be equal to 0. We know our derivative here, which is our slope, is dy dx is equal to 4x minus 2xy over x squared plus y squared plus 6. If you want a fraction, or your slope here, which is a fraction, to equal to 0, that means that your numerator must equal to 0. If we set 4x minus 2xy equals to 0, note that there's actually two variables here in this equation. Luckily for us, both of these terms have a common factor of 2x. If we factor out 2x, we are left with 2 minus y. Since these two factors multiply to give us 0, that means either 2x has to equal 0, or x equals 0, or 2 minus y has to equal to 0, which means y is equal to 2. If that's the case, we have now two different x values and y values. I don't know if they go together or if they're separate, so we're going to have to look for horizontal tangents for each of these variables separately. So let's look at the first case. Let's say when x is equal to 0. First of all, when x is 0, we know that our derivative is 0, so that seems to work out in terms of having a horizontal tangent. The question is, what's going to be the y value for that curve? Because remember, when we have horizontal tangents, they come in the form of y equals to some number. Well, if you recall, they actually gave you the original equation above. So we know that we have 2y to the third plus 6x squared y minus 12x squared plus 6y equals to 1. If we substitute in when x is equal to 0, all the terms with an x will become 0, and we'll be left with the terms with y. So we would have 2y to the third plus 6y is equal to 1. If we're still trying to solve for y, because remember our goal is to write the equation of this horizontal tangent, we can set this equal to 0, 2y to the third plus 6y equals to 1, minus 1 equals to 0. And we can put this into our calculator and solve for y. If I go back to my Desmos app here, okay, and we plug in our equation of having 2y to the third, 2y to the third, plus 6y minus 1. Oops. Actually, we're going to have to put them in terms of x's. X and x. There we go. Okay. We can actually go back to our graph and see when does this equal to 0. Let's look at that root. That root occurs when y is equal to 0.165. That means for this particular example, when we deal with the equation of the horizontal tangent line, that horizontal tangent when x equals 0 is going to be y equals to 0.165. The coordinate that passes through the graph will be 0, 0.165. Remember, the horizontal tangent is just in the form of y equals because it's a horizontal line. In addition to that, if we think about the other value that we found when y is equal to 2, okay, we actually know that that's going to be the equation of the horizontal tangent, y equals to 2, because that comes in the form of y equals. However, let's also use the equation in the same way to solve for the x-coordinate at which that occurs. If I'm using the same original equation that we have here, I'm going to duplicate this over and just make it a little smaller so we can see it better. Okay, if we substitute in when y is equal to 2, that means that we have 2 times 2 to the third, which is 8, plus 6x squared times 2, minus 12 times 2 squared, whoops, that is not 12x squared, plus 6 times 2 equals to 1. If we try to solve for x here and we start combining our terms, we have 16 plus 12x squared minus 12x squared plus 12 equals to 1. If you start solving here, you actually wind up with the positive 12x squared and the negative 12x squared canceling out. So you don't have anything there for those terms except for 16 plus 0 plus 12 equals to 1. If we add them together, that gives us 28 equals to 1. Wait, that caused a problem. Actually, y equals 2 is not a horizontal tangent. Notice we had to justify that that point lied on the graph and if there was a coordinate at which it occurred, which there's not. So we must be careful here when solving for horizontal tangents. Let's just recall. When we're finding a horizontal tangent, we have to set our derivative equal to 0. That means that the numerator must equal to 0. We're going to solve for both values for x or y if necessary to see where that occurs. In this case, we got x was equal to 0 and we got y was equal to 2. Then we had to make sure that these points actually existed on the graph. If I look at x equals to 0, when I substituted that into the original equation, we got y equals to 0.165. A horizontal tangent in this particular case was y equals to 0.165. Remember, horizontal tangents coming in the form of y equals. The second value for the variable, y equals 2, we went to solve for the x-coordinate to justify that it existed, and we found that y equals to 2 is actually not on our curve. Therefore, there is no horizontal tangent when y is equal to 2.